This is not a globe of the world. This is instead a polar projection map projected onto a sphere. If I want to make it into a globe of the world, it's very simple. All I have to do is take it off its hinges. Whoop. So simple. And I've actually got two sets of holes drilled in this globe. One set of holes is drilled where it's supposed to be drilled, in the North Pole and the South Pole. There's the North Pole, and down here is the South Pole, or vice versa. But the other two sets of holes I have drilled in here, one of them is drilled in this spot right now. It's drilled in Boston, Massachusetts. And the other hole is drilled at the opposite side of the globe from Boston, Massachusetts. The Antipodes. Right. Which you have to actually calculate. It's not that hard. But you have to calculate from the latitude and longitude of Boston. You can calculate this, and it's pretty straightforward. If anybody has trouble, they can come ask me. But what happens when you hang it like that is this now becomes a polar projection map centered on Boston, Massachusetts. And it's kind of a fun thing. It's useful, too. If you're going on a de-expedition to someplace, you want to know what you're going to see when you get there, you can take and drill a couple holes in the globe and rehinge it and find out what it's like from, say, Tajikistan or wherever it is you're going with your expedition. So it's back to being a globe of the world. I took it off its hinges. So that's it.
Thank you, Bill. You go too many places, you never will.
I'm Tom, W1PKX, and I brought my transceiver in that I've been working on for the last 2 years or so. And I started designing some of the circuits for this back around when COVID hit. And my goal was to design a CW transceiver that was, high performance, high dynamic range receiver, and some transceiver that's got performance specs competitive with, the top line transceivers today. So it's all analog. Right now it's a 5-band transceiver. And ultimately when I get around to finishing off the filters on it, it'll be a 7-band transceiver. It's a 40-watt. I've got a pair of LDMOS transistors in the final for the transmitter. And when I said high dynamic range, it's 103 dB, 2 kilohertz spacing, and very low, very high reciprocal dynamic range as well. So it's pretty competitive with most of the top transceivers now. I designed 4 circuit boards for it. The largest board here is the receiver, which has a bunch of 3-section bandpass filters, an H-mode switching mixer, a high intercept IF amp. Crystal filter is an IRAD 250 hertz crystal filter, and it's got a very high bandwidth AGC system with a very high fast attack with adjustable threshold and slope on it. The output stages there are, I've got 3 sets of analog bandpass filters, 400 hertz, 250 hertz, and 150 hertz. So those are when they're in full cascade, there's about 14 poles of audio filtering in it. So it's a very selective receiver. This spring, I designed a digital exciter board to implement a DSP windowing function for the transmitter, so that the key wave shape is shaped by a hand windowing function. And let's see, the transmitter is, as I said, 40 watt LDMOS. I've got on the outputs here, I have outputs, wideband IF output that I use to drive an Elecraft P3 pan adapter. And I've got outputs here to drive, I have a companion 300 watt LDMOS amplifier I designed, which ties into this, so I can use this to control power on the amplifier and do all the band switching automatically. And I just last month added an RS-232 port with a cat command interface, so I can now run N1MM logging programs on it. So eventually, I hope to. I'm gearing up to try a few CW contests with it, so I had to add that in.
Well, that's incredible. Nice job.
From the front.
Oh, yeah. Controls. Controls, AF and RF gain. So the three small controls here are optical encoders. This one controls AF and RF gain. This one here is the passband tuning. They're all multifunction, so passband tuning and power set. And this one here is VFOB or RIT, depending on whether you're in split mode. The transmitter can be put in split mode, so there's two VFOs. And the main VFO-A is a 256 pulse per revolution magnetic encoder. So I have three buttons down here. This button here is the, let's see, what is this one now? This one here is the AGC. So I can have AGC off. I have three different AGC hang times. I can do fast, medium, and slow hang times. This is a filter select button for selecting the audio bandpass filters. And this switch here is the preamp and attenuator select buttons.
Good job.
Nice job.
What do you use to control the display and interface it to that?
Oh, there's an Arduino Mega in here running an operating system to control everything.
Do you do any EMI?
No, I haven't had, I don't really have any problems with it at all. I haven't got much of anything in terms of, I got one tiny spur on 30 megahertz, which is a function, I believe, of the A to D converter that's running here, because if I change the settings on things, you can hear it shift slightly in frequency until it settles back down. But
When you go into
Don't
production.
tighten the cover back up, please, until after we've had a chance to talk.
sure.
What's your first IF on that?
It's a single conversion, 8 megahertz IF.
That's where you stand for.
Yeah, so it's the receiver's all analog, so it's an 8 megahertz single conversion, and
Oh, you're not going into an AV?
no, yep, it's totally analog.
I don't like it that way.
Yeah, no, I much prefer to have an analog one. It's much better. You can get much better AGC action, and I've got it all designed out to have very low group delay distortion. So on CW, it really sounds nice.
What did you use for filters?
For the IF, I'm using an INRAD 8-pole crystal filter. That's the main selectivity at the IF stage, and then I have 3 stages of audio bandpass filters that are cascadable, and those were all designed to have optimized for low group delay distortion. So
When you're going into production.
well, if it took me 3 years to do this one, I'll put you on the waiting list.
How many can we put you down for?
Put me down for 3.
Of course.
Hi, my project fits somewhere between the globe and the fancy radio there, the spectrum. As we use the word brew, homebrew, it's tweaking, twiddling RF circuits or radios, and I'm introducing a different medium, plastic. So I think, as many of you know, I've been taking a dive into 3D printing for most of this year, started in January, and you'll find if you get into it, literally millions, roughly 10 million models online that you just download and send to your printer. And there's a little bit of finesse involved sometimes in rendering the prints so that they turn out with the properties that you want. And there's a full spectrum of different filaments that you use that give you different properties too in terms of durability, robustness, strength, and so forth. So I brewed an accessory here. Obviously, for most brewing projects, you use test equipment of one sort or another. And this one item that I located online was a model here for a probe holder. You snap your two probes into it, and now you can operate your meter probes conveniently with one hand. So if you're going through a batch of batteries, or if you're in capacitive mode, you want to measure a bunch of caps or something. Anytime you need to have your probe tips held together, this accessory does it for a few cents worth of plastic. Not something you're going to use every day, but something you can hang on a nail, above your bench and have it handy. So one of the issues that I found when I printed it first was that and by the way, I had no problem, just the model off the internet fit my probe. So you probably never measure the diameter of your probe barrels, but it seems like it's a pretty universal dimension. There is a smaller one for the kind of Harbor Freight mini free meters, and there's a separate model that fit that size perfectly too. So it seems like there are just two basic dimensions. So again, I downloaded the model and printed it, and it printed initially pretty much flat like that, came out very clean. But I found that when I tried to snap in, or when I tried to move the barrels, the side of the barrel flaked off and it broke. And so the idea there is when you print something, it's built in laminar form, each layer being about 0.2 of a millimeter thick. And so it just goes over the full dimensions of your item, adding 0.2 of a millimeter at a time. And you can print things a foot tall, and obviously that will take a few hours, but it does do it with amazing detail. So to overcome that strength issue, I changed the orientation of the laminations by printing it vertically. So you end up with what looks like this, two of them being printed side by side. And that introduces another feature I think a lot of you can see. There's like a pillar in the center. And the reason for that is kind of obvious, that you can't print the top of this when there's nothing beneath it. The hot plastic has to rest on something, else it'll just fall down to the base plate. So the software, the printing software, automatically constructs for you, as it's going up layer by layer, a center scaffold, so that when it gets cantilevered over far enough, there is something to put the hot plastic onto, and it's the top of that center pillar. That's all done automatically for you. You can turn it on or turn it off.
So that worked better for you?
Pardon?
It worked better for you as far as the durability?
Oh, and then the strength here, this piece didn't have the problem of breaking there. So it does introduce the issue of having to peel off the support material, right, which can be formidable and something, again, that you have to learn how to manage. But Les has asked me to be the February meeting speaker on applications of 3D printing for ham radio. And so I will be doing that with some more in-depth items. So I can pass this around to people who want to look at it. Put these in a bag. I'll ask you not to peel the supports off so other people can see it. We'll start there and go back around.
What printer do you use, Jim?
I have a Bamboo Lab printer, P1S, and be happy to talk to anybody about it if you want to.
How do you get the center support out?
The best way to use is to use a pair of needle nose pliers, and you wiggle it a little bit and it'll come loose. One of the parameters you can set is the spacing between the support material and the object that you're trying to print. down to, again, resolutions of a fraction of a millimeter. And you can make that larger, and it makes the support material easier to break away. And if you don't put that dimension in at all, your support material can become part of your object, and it's basically impossible to remove. So.
Interesting. Thank you. Thank you, Jim.
Charlie, AB1ZN. I was given this.
Talking to the microphone.
Well, I should just hold it. Oh. By the family of a silent key. And I've had it a few years. It's a Crosley 50, vintage around 1925. And it's regular broadcast and some shortwave. I did have it working at home, but I need quite a large antenna. And I did pick up a signal frequency on that. But I put together a battery pack with some D cells and some 9 volts, so there was enough to power it. This doesn't draw very much. The interesting part of it is the tuning capacitor is a fixed plate, and as you rotate this, the other plate's on a spring, and that gives you the signal there. The other part is this is a push-pull with these coils. Okay. There's a selector on the front, and we put it on position 4 for just a standard broadcast. There's another adjustment here for the this one here is the filament rheostat, and I kind of kept that down on the low end. The real touchy, I mean, again, I had it with these very comfortable headphones. I used those. Was able to tune it in. We kept the rheostat low in position here with this control, and then these grid plate coils. We moved them in. I moved them in and out, and I was pretty satisfied that I did pick something out. The other thing you can do with this is have an amplifier on it, but I just chose the vintage headphones, high impedance headphones, and like I say, I played around with it for a while, and it was good. This is not the tube that was in it. It's the same one, but well, this one actually was. It worked in the kitchen. I went up to the shack. It then quit. So I had another old radio with the same tube, and I put that in and got it working again. I would have had nice to have it running tonight, but it needed. I hooked it up actually to my dipole. I had that hooked up as an antenna. So that's it. Yeah, it was interesting. I had fun with it. It's interesting. I like the old stuff.
100 years old.
100 years old. Yeah, 1925. Yep. Yeah, manufacturer under Armstrong patent. It was for experimental and ham use, and because it's Crosley, if that name was pretty popular for all types of different things. They didn't just build these, but the ones I looked at had a wooden enclosure in that. But this is the way I got it, so I thought it was interesting.
Yeah, thank you.
You're welcome.
So I'm Mark, and I'm a receiver-holic.
Hi, Mark.
So,
He's on the kind of step program.
yeah, I'm trying to quit, but it's real hard. So I've been after one of these 75A4s for a couple years now. I'm starting to see the prices go down on them at Haas Traders, and unfortunately I tend to miss them. Someone else always scoops them before me. But a few weeks ago I went down to the Vintage Radio Communications Museum in Windsor, Connecticut. I don't know if any of you guys have been there before. Highly recommend it. It's a great museum.
Awesome place. Anybody here, you would absolutely love it. It's worth the drive.
Now, 6 times a year they have a flea market there, and in the wintertime it's small because it's indoors. But in the summertime, it's out in the parking lot, and much bigger crowd of people selling. But the cool thing about this museum is they have a lot of stuff that was donated to the museum that they sell in order to fund the museum. And this time, there's a whole bunch of Collins S-line equipment all up on shelves and stuff. And sitting down on the bottom shelf on its side, looking very forlorn and you know, lonely, was this receiver. And it had a little note on it that said, you know, it had a couple problems with it. The endpoint adjuster was messed up. The little needle on there was bent. It didn't work in sideband or CW mode, only in AM mode. And they plucked the AM filter out of it to use in their actual ham station that they have down there. They have a 75A4 with a 6-meter converter and a Clegg transmitter that they use for 6-meter operation. So I bought it for what I thought was a reasonable price and got it home and went through it. It's a low serial number. It's only serial number 270. And there was a ton of updates that happened. I think they made thousands of these things over the years. And the updates apparently were done on this receiver. There was documentation that came with it, and you could tell the owner of it really took good care of it. He had all the filters in it, and he installed the 4-to-1 vernier drive, which wasn't in the early serial number units. This is the one serial number 270. And so it's been around for quite a while. Unfortunately, the gentleman who owned it, I've learned when you get boat anchors, find out the history on it. It's really important to dig into who owned it before and kind of get the provenance of it, because these things are becoming kind of collectible, and you know, it kind of raises the value if you can tell a story behind an antique. Anyway, it's K1. He wrote his call in here. I have to put on my glasses. His name was Ronald Bumstead, K1QYG. He's down in Connecticut, and he worked for Northeast Utilities, and he passed away in March of this year. And his family donated a whole bunch of his gear to the museum. And anyway, I'm really happy that I was able to get Ronald's receiver and to get it working again. It had a broken wire on the mode selector switch. Quite a few tubes were really low on emissions, but first thing I did was fired it up and brought it up on a Variac, of course, and checked to see if all the crystals in the local oscillator were working, because sometimes those will conk out and it's a pain in the neck to find another crystal. And they all worked, and it actually had very good sensitivity on all bands. PTO was off by 8 kilohertz. That was really the only thing that seemed to be wrong with it as far as alignment goes. I still haven't fixed that, but I will. These things are notorious for having bad capacitors in them. They're 14 black beauties down below, and even the silver mica coupling caps tend to leak on them. So I'll be going through that and fixing it up. Since the AM filter was plucked out of it, I cobbed in an R390A 8 kilohertz filter, and those will drop right in without any modification to the circuitry. And that gave me good AM quality audio. The AM on this without an AM filter is horrible. So and I like operating AM, so that was a big detriment. So once I got that filter in there, it became very usable as far as I was concerned. And I do have its older siblings, 75A3 and a 75A2, as well as a 51J4 general coverage receiver. So this kind of completes the whole set of Collins receivers from that generation.
Was that expensive?
A couple $100. It's not that much, yeah. Yeah. I mean, I've heard of people getting them for less than that, but sometimes they don't have the filters or the vernier knob on them. Those are all upgrades.
It looks like it was in good physical.
Yeah, he took really good care of it, and that was the thing that really sold me on it, was how clean it was. Okay, that's it. Now,
So I'm Mike, WU2D, and I live in Hooksett. Really, it's closer to Manchester, southern part of town. I have a YouTube channel called Microwave One with a K, and I've been doing YouTube since the beginning. Matter of fact, I just got contacted by them that I hit my 20-year mark on YouTube, which is, I can't even believe it. 20 years on YouTube. That's nuts. So this is just some of the stuff I built for the channel over the years. Probably the one over here is interesting because it's a circuit board that I developed with my harmonic, who is a 3D printed nut and an engineer and also an artist. And he did this circuit board for me for a Chuck Kitchen high-performance regenerative receiver as written up in the ARRL handbook. So we did a board for it, and we've sold hundreds of these boards to people who want to do a plug-in coil regenerative receiver. A lot of fun. This is a noise canceller, kind of like the old MFJ noise canceller. You have a noise antenna out in the yard, like a vertical, and then you have your regular receiving antenna, could be a dipole or something, and you can dial out the noise. I developed this when we had a light on the street that was arcing, and it was going, ah, right, and that was a wonderful check target to build a noise canceller with. And then when I saw the guy repairing the bulbs a street over, I got him to come over and fix it. But that light helped me out. It got me a nice project. This is a 10-meter double sideband transceiver. I built this last year. This guy, I made all kinds of contacts on this thing up on Pawtuckaway, up in the mountain. Basically, you just take a little roll-up dipole, hook up to this thing with a little lithium-ion battery and a microphone, and I was making 10-meter contacts, no problem. It uses a direct conversion receiver on 10 meters, okay? So it actually has to have a preamp. You don't see many direct conversion receivers with preamplifiers.
Is that in QST?
No, this isn't in QST, it's in my head. It's all built with popcorn parts. I decided I was not going to use anything that you couldn't get now. So it's like all built with 2N2222 transistors. Okay, so that's a fun little project.
Do you have problems with microphones with the direct conversion that high?
I'm using a VXO, so it's a variable crystal. And this thing is, I've got a YouTube video. You'll think I'm using a Yaesu. It's that solid on 10. This is a replica of a World War II Paraset transmitter receiver. This was developed by the SOE in the UK, and these were dropped by parachute into France in World War II. This is a one-tube transmitter, puts out about 4 watts of CW. The key's built in, and has a 2-tube receiver. It's a regenerative pentode into 1 stage of audio. And this is made for like you basically take your 6-volt car battery out of the car. You carry the car battery up to the attic of this building in town. You drop a 20 or 25-foot wire out the window. It has a vibrator power supply. You quickly make your transmission, roll everything up, put the car battery back in the car, and get the hell out of Dodge. Because the Germans were so good at radio direction finding that they actually had, well, they had systems with panoramic adapters on them in France. And basically they could see when signals would come up, just like we do with our DSPs today, okay? And then they had 4 radio direction finding systems where they could pinpoint the basic area where you were. And then they had both aircraft and they had drive-down capability with portable direction finders. If you've seen all the light that can't be seen. If you've seen that movie or read the book, that DF set, you put that in a car and you can basically get to the building now. And then they had a walk-down system. So this is a walk-down system in your coat where they can actually get to your door in the apartment. So they were going to get you. And basically every agent that used these spy sets in Europe was captured or killed. All of them. All. Okay, so it's just a matter, did some escape? If any survived at all, it would be a miracle. Because people do stupid stuff. They go to the same building the next time. They get lazy. They want to go to the mountaintop and they think they're okay in the mountaintops. The last place you want to go is the woods. You want to go to the middle of the city with your spy set. You want to be in the most dense urban environment you can. That's your only chance of survival. You think, oh, I'm going to go up in the woods and make a transmission. Well, that's the easiest for them to find you. And so that's the Paraset. Anyway, these are like projects that I do for my channel. And if you're interested in any of these, I'm sure there's plenty of videos on them. So,
What's the name of the channel?
Microwave One with a K. Yeah.
I think some of those spy radios were manufactured by Bang and Olufsen in Sweden. Is there any evidence that's one of those radios?
Well, there's spy sets, and this is a guy who collects spy sets, by the way. There's spy sets for all the countries that basically have military.
I read this and I can't even remember where, but I was impressed because Bang and Olufsen is now in this hi-fi business, and apparently they were supporting the Allies from Sweden.
Delco, a division of GM, used to make our spy sets, our U.S. spy sets. So.
But I think the British government actually built most of the spy sets that were used, at least by the Brits and the French. But, it's possible that they got the plans for these things and we're building them in other countries too. So Bang and Olufsen, why not?
The other thing about spy sets in general, just because they find you doesn't mean they want you off the air. So once they identified that somebody was using one of these, and they might identify it by the regenerative receiver being in the oscillator mode. You don't even have to transmit. They got you. They would let you continue to transmit because they wanted to find the whole network. Or better yet, they would have you, they would understand your operation so well that when they finally did capture the set, they would pretend to be the operator to find the rest of the network. There was no chance that these people could survive. It was a suicide mission to be a radio operator in France.
Did they know this going into it?
Yeah, they did.
And did they have any kind of training for the use of this?
Oh yeah, they did. They did. I actually was in the Special Forces Club in London. I was working in the military area, and there were pictures of all of the agents in World War II on the staircase and all around, and most of them were women. So most of these operators were women.
Is that because of naval dexterity and being able to use the view?
It was because you could have women in France and they wouldn't be suspected. They could be telephone operators. They could be,
Bakers, whatever.
whatever, yeah. Yeah.
Young military age man walking around not in uniform, kind of suspicious.
One of the things that I learned was that the Germans were so good at picking out these radios that they would build them into suitcases, the cheap cardboard suitcases that carry them around. And they learned how to recognize the latches that were on the ones that were provided by the British government. So the first thing they do is they told them, look, when you get the radio, find a locally sourced suitcase, something that's beat up, and take the guts and put it into that and throw out the one that we gave you.
Otherwise you're advertising.
Yeah, exactly. But that's how clever the Germans were about spotting this stuff.
What frequency did they be transmitting?
This set operates between 2 and about 7, 8 megahertz. So this does 80 and 40 meters. My best contact on it was 3.505 megahertz, right on 80 meter band. And I called CQ boldly with my 4 watts, right, middle of winter. And a German answered. Now, so DX, right? A German answered. So we're going back and forth. And the more we're going back and forth, he realizes what this is. Because he was in World War II and he used to hunt these.
Oh my God. Well, he found one.
He sent me the card and 50 marks. Wow. And the 50 marks were for my son, who was going to be an exchange student in Germany. But yeah, I have the whole deal. But he was not in the Aboire, which was the hunters, but he was in the DF Corps, where they had a command car, they called it, and they had the loop antenna on top. Yeah, but it was, this is about 20 years ago when I first built this.
Yeah, good presentation. Another.
Yeah. Well, you got to get this guy to do it. He's got.
Maybe we'll do it together. I'll bring in my spy radio.
He's got stuff that'll blow your mind.
Hey, you guys, before you leave, we're going to set you up.
Sign me up.
You come to bed for my chance.
No, there's the B2 was the most popular one. That's the one that I have at home. And it's much larger. That's the one that you find in the suitcases. They weigh like 30, 40 pounds. So these women, these delicate French women were carrying this heavy thing. And there was one famous operator, Mike can talk about her, that had a wooden leg.
Yeah.
And she's carrying one of these things around. Did she get captured? What happened?
What was her name? It was
I can't remember now.
Virginia. Virginia, I can't remember her last name. She was American, and she volunteered and survived. She actually survived. She was not a radio operator, though, but she did operate the radio. She learned in place over there. But
have you seen the movie? I forget the name of the movie now, but it does show the car and going around.
Yeah, this set is made to work on a 6-volt battery, 6-volt car battery.
Is that what they had in Germany and in France at that point?
The cars had 6-volt batteries.
Yeah, that sounds like a British car. We used to use 2 6s.
Well, a lot of them have vibrator supplies that run off the regular 240 or 120 or 6 volts. I mean, it was multi-voltage type of power supplies.
Anyone who knows anything about the British Leyland vehicles, the early ones, they're 6-volt batteries.
Yeah.
Sometimes positive.
That's right. Yeah.
Well, thank you guys for bringing that in. I appreciate it.
One of the problems I have is I haven't done CW in years, and I'm trying to get back onto it. And I have a bencher keyer. This is the weight for it, but I have arthritis in my hands, so if I use the DAW side, right here it clicks, and so it bothers me. And one of the things, so I have to be heavy-handed, and so the keyer would walk across the desk. It drove me nuts. So what I did is I created an 8-pound bass. So what I did is I went and got a bread pan, and then I ran it through my table saw. Do it slowly if you do this, because aluminum will fly everywhere, and you won't cut well. You have to do it very slowly, and make sure it's a carbide blade. Anyway, then I went to Home Depot and I got lead flashing, and the lead's in the back, and it's 8 pounds of lead. And what I did is first I used a Napa torch. That didn't work. It's too slow. So I went to my I have a camper two stove camper propane, and I turned that on, it's a huge thing, and it really is hot. And I had an old pot, so I threw all the lead flashing into it, make sure I was upwind. You don't want to be downwind on this. And so I started melting the lead pretty quickly. And so there's a lot of, how should I say, flashing has a lot of slag in it. So you have to scoop all that out. And then you find out you have to add more lead. So I put in a ton of lead to get just a little bit of pure lead. So, and then what I did is once I got this and it cooled down and everything, you pour it from the pot. Don't use that pot again. Not a good idea. I would put this on top and just drill one hole and put a screw through it so it won't move. Then I would drill the other ones. And then I transferred everything over. And this thing is great. Doesn't move. It stays right on my desk. If I put a mouse pad on there, it definitely doesn't move. So, yeah, it works great for me.
Cool. Solve the problem.
Yeah, it did. If you want to pick it up, just be aware it's heavy, and don't pick it up by the paddles.
Oh crap!
Oh yeah.
Okay, I'm Steve, NA1T, and usually I build Go boxes in these things. I design and I build mostly for Aries because we have a ton of different radios and we have a ton of different requirements. However, sometimes a radio doesn't warrant a Go box. This is called a Go board. It literally is a breadboard with a handle in it. So when I don't value the radio very much, I'll put it on one of these. This one is one of those Regenerative radios for GMRS that CERT uses. So I needed something very quick and dirty, and it just works. Now this one, and all this stuff is done by power poles, by the way. I don't fuss with anything else, as most of you already know. This one is amateur and commercial. This is PowerWorks. I don't recommend this radio, by the way. It will drive you crazy. This one is bamboo. This one is teak. And this one happens to have a rig runner on it as well. But, and it's got a place for a signal link and a place for the microphone. So it literally is grab and go. They both are. They take about an hour to put together, you know. You're supposed to, most of it's just measuring. But that's it. That's all there is to it. Right? And I actually stuff them in one of my Go box boxes. So these are called Go boards.
Very good. Oh,
John.
What's that?
Did you say you do DMR?
No, these are not DMR. I would GMR. It's FRS and GMRS. This one does it all, plus amateur and commercial. They call this a commercial radio. No one in their right mind would call this a commercial radio. Unbelievably difficult to use. We channelize everything. God help us. And that's the only way you can actually use these radios. They're terrible. But CERT doesn't require amateur radio licensing, so that's what we use.
Hi, I'm John, KK1X, and I I cloned the DX Commander antenna for a contest a couple of months ago. I wrote an article about it in the Signal, but this is the antenna. It all stems off of this 41-foot mast. I'm not going to extend it all out, but along the mast I've got little tape marks just so that I know what's going on. This gets positioned and set up it as a guide mast. It's very straightforward. But then I take and I just use electrical tape to apply these supports. This is just the feed point, you know, that the coax screws in here. Elements for elements for 10, 20 and 40 go on here. The 40 element or the 40 meter element also gives me 15. So it's a 4-band antenna. This gets taped to the bottom of the thing, and the elements are screwed to it. And these get placed at, along the tape, on the tape marks along the mast, just to keep everything from flopping around. And I have a bunch of elements which have this really cool orange shock cord to keep everything tensioned. And at the bottom of it, I need radials. And I just have a kit of radials that I use for all of my vertical antennas. And those just plug into this mess of connectors here. And that's it.
And so that's what you use for your POTA stuff?
No, I use this for the sweepstakes.
Oh, okay.
Yeah, this is it's too much to set up for a POTA thing. It takes like 45 minutes or so to get everything built and put up, but it works.
It works well.
And it was relatively cheap because I already had the mast.
Well, thank you.
Mine's more of a question than anything else. Add K6PNL.
Okay.
And I do quite a bit of POTA, and I've been trying to figure out for mounting my battery and all my accessories. And for the longest time, I've just laid them loose in here, knocking them around. And there, some guys, I've seen some other people, and they say, why don't you just mount this stuff? But I'm one of these guys that can never make up my own mind how I want to do it. So I've been trying to figure out what I want to just take and mount this. My fuses on the side, mount this up here, and forget about having the cushion on the thing. Also mounting these here, because these are so I can regulate power for a computer. And I'm just trying to get some different ideas.
This sticky Velcro that you
Yeah. Well, well, it is. It's not, Velcro's not permanent if you use a little bit of it, but if you use too much, I can't get my battery back up. I put four strips in the bottom, commercial grade Velcro.
You need a crowbar. Well, the easy passes, right? With the connectors on that. That is dual lock from 3M. It's heat resistant. They use 100 hooks per square inch. You can get 250 and 400. 400 you will break your thumb before the part. But 250 is what I use. This is 250 on this one. That's what I use for all of my stuff.
So that'd be a good idea then.
And it's a whole lot better than.
Okay.
And I will say that if you write to the Mass Department of Transportation and say, I have a new car, they'll send you an envelope with about 10 of them for free. If you really want to be frugal, ask me how I know.
Hey, wait a minute. Now you're telling me to do something that's a little.
Hey,
and Rob TV. Yeah, anyway. Awesome. My other question, anybody around here play with DVMs at all? Well, yep. Yeah, apparently not. From my house, there isn't any, I can't hit any repeaters with a handheld. So what I finally did at my house, I went and bought a pre-built DVM, and I have it tied with my DMR, and I have a whole bunch of DMR channels programmed into it. So if I want to talk to a friend in California, I switch over to where I could usually find him at. But now I bought another one, and this is called a dual hat, and it will allow me to do split transmissions, just like we do on repeaters, except on the dual hat. And I didn't know if anybody else in the club was playing around with them or not. Okay.
Not me, but
No.
maybe somebody else is.
Anyway, but that's my little project I'm working on. I have a KX3 that I'm mounting in a bigger case to do POTA with.
Very good. Thank you.
Yeah, I'm Rod, WA1TAC, and this is not so much a project, but a bit of a discovery I made. I was up at Nearfest last year sometime looking for a box for another project, and there was this nice little aluminum case, a couple of coax connectors on it, and it said low pass filter. And I said, okay, well, I can always repurpose it. But then I took the case off, and it was just immaculately constructed inside. Nicely wound coils, quality capacitors, and let me digress and say, well, low-pass filters were kind of a necessity for hams back in the 50s and 60s when vacuum tube transmitters were common, and they generated a lot of harmonics. At the same time, or a little earlier, the 15 meters was approved for amateur use at 21 megahertz. A lot of the TV sets had a 40 to 45 megahertz IF intermediate. So a strong signal at 21, so harmonic is 42, and the same thing with 20 meters with times 3 is right in the band. So in a densely populated area, low-pass filter on a tube transmitter was a necessity to add a more attenuation. I found an article describing this one perfectly in a 1958 ARRL handbook. The coil dimensions matched everything, and the capacitor settings look like they're right. So I don't have a vector network analyzer, but I do have a signal generator that runs to 50 megahertz and a scope that does the same. So this is a 50 ohm version, so signal generator one in one side. It's symmetric, so it doesn't matter which one is the input or the output. And a scope with a terminated in 50 ohms, so you don't get reflections. And it's very little amplitude change up till about 33 megahertz, maybe 35, and then it drops like a rock into the 40s and 50s. There's a bit of ripple in the pass band, so but not much. Certainly no more than a dB. So it's a nice little relic from years, a decade, half a decade, or 5 decades ago at least, maybe 6. So it'll remain as a relic on my shelf, but too good to tear apart and repurpose. Yeah, that's it. Pass it around, but please don't tweak the capacitor settings.
Hi, folks. So I'm Phil W1PJE, and like other people, I have equipment disease. And in particular, it's, you know, if you like the history of technology, as Mike does quite a bit of, for example, there's some interesting things rolling around out there. And so I'm going to these two are kind of coupled here. So I don't know if anybody recognizes this. This is a Zenith transoceanic, which was from 1949 till about, they went solid state in the early 60s. This is not solid state. This is a portable radio because the guy who was the CEO of Zenith at the time he was a sailor. He wanted something he could take on his boat. So that's a 6 tube. That's basically an all-American 5 with an extra RF, a pentagrade converter on the front, which kind of looks a little like this. Unfortunately, the 1L6, which is this right here, is now beyond unobtainium. If you go look for this on a list, you will pay $400 for one of these, because there's a whole story behind that we won't get into. So this little 1R5 here, you can drop this in. However, it won't go much above 8 to 10 megahertz. It's a little bit more limited. But this was in the era, of course, being portable, you want to run this thing on batteries, right? You don't want to have to plug it in. So they were very clever about this, in that there's basically a spring cord here, and if you want to plug it in, you could plug it in, and if you didn't, you would basically kind of push this thing back, plug it in right here,
And now you're running off batteries, a 90-volt battery and a 9-volt battery. The 9-volt battery is for the filaments, because these are all battery tubes. These are all ones, which mean that the filaments are like 1.5 volts. And so there was a 90-volt battery in here and a 9-volt battery in here, and there are people who have taken 60 1.5-volt AAAs and made a little box out of it. So you would plug that in here. It's actually reasonably sensitive, and what I like about it is the wave magnet, which is the AM particular antenna, with this little sort of, they give you suction cups, and then there's this which you can take, and there's a picture, and I wish I had brought it, of this hooked to the window of a Pullman car. So that you could, while you were going to sleep, stick this thing on the window of the train as it was going along and listen to AM. Now, if you wanted to do shortwave, well, there was a solution for that. That essentially, you did this, and you had a reasonably okay. So I haven't recapped this. It's got lots of fun stuff, and I have to take that out. But anyways, this is waiting for restoration. So, you know, a lovely little thing, and this was probably in the last 2 or 3 years of them making a portable shortwave set that was all tubes. So that's great. But what if you don't know anything about your tube, right? Okay, we all know that sometimes tubes are not exactly these are fairly robust, right? If you're trying to restore something, you know, odds are often that the tubes are doing fine. But let's say you want to check those out. Well, the audiophile community has, of course, gone crazy for some tubes, and now some tubes that, like the 12AX7, are just getting ridiculous. But if you want to test them out, that's the second thing I brought. So, let's suppose it's the 1950s and you're a Bell system engineer. Your central office is filled with vacuum tubes. You're a line person, your job is to fix the rack that's not working. Or in my case, maybe test the tube. Anybody played with vacuum tube testers here? Usually there's a roll, right? And you look up such and such and such, right? Well, they didn't want the technician to do that. So Western Electric, and for those of you who don't know, before the Bell system was deregulated, Western Electric was the equipment manufacturer. They made all the telephones. They decided to make a tube tester. That's what this is. Ugh. Yeah, that's right. Skip is right. It's portable because it got a handle. This is something called a cardmadic. And I can even take off the top here because they thought of everything. So this is a tester, but it's automated. So the question is, how do you automate things? Well, it's the 1950s. This is from about 1959. You make punch cards. So instead of looking up on a little roll what the tube is and getting it wrong, you would basically kind of, the poor guy, these, by the way, this was made to military specifications or telephone. These are the calibration cards. There are 51 calibration cards. This is accurate to 2%. It also does mutual conductance, which if you look on eBay and you ever see a tube tester that says mutual conductance, the price immediately doubles or triples because that's the measure of how much current is going to the output of a tube for how much is going into the grid. And, you know, the real test of a tube, of course, is put it in the circuit and see if it works. But there's a bunch of people who, of course, want to test things. So they wanted to make this as simple as possible. So the poor guy would say, he's got some rack of equipment. Oh, let's say that's a 1R5. So then he would take his other case, put that down, open it up, say, oh, okay, I'm going to look in here. I'm not going to look for the 1R5. I'll say, there's the 1R5. You push the plunger down. You stick the card in here. And if this were powered up, there'd be this nice clunk. You let the plunger up. There's an 11 by 17 pin matrix here. And that's what programs this tester for a set of conditions that you could actually find in this nice little book here. But the technician doesn't have to do anything. They take their tube. That's right. Yeah, they have to run the 51 card calibration every so often. But you take your tube, you find the right socket, you plug it in, and you basically push one button. Is the filament okay? And this button would test gas, and then you get a conductance. But you don't. Who wants to look up the conductance in the book? It just says good or replace. And then you'd break your arm putting this back in the truck because you had to do that. But the weird thing about this is that if you look through these tubes in here, 90% of them you've never heard of because they're relay tubes for the Western Electric circuits in what used to be a central office that was filled with tubes. And batteries. Because you don't want the phone to go away, and that, if the electricity went out, there was all of these lead acid batteries, as Rod said, in the central office that made you still got a dial tone. So the amount of engineering that went into this thing is completely crazy. Not only did you have this, don't make a mistake, let's suppose you lost a card, right? Well, if you lost the card, then, let me see if I can get this out of here. The problem is this thing is a little bit hard to get out of here. They gave you a punch. I'm not kidding. And then the poor guy would say, here's a blank card. Punch your replacement card. I don't know how they know how to do that. And the annoying thing about this is that you notice that it's mostly holes. That's because the switch means there's not a hole. So this card has maybe like 10 connections, but you have to punch all 11 by 17 minus 10 cards. I've tried it. Your hand hurts. And so the engineering on this thing is just completely insane, all to make sure that no one made a mistake testing the tube because, there's a rack of equipment, probably the supervisor's yelling at you, this circuit is offline. I don't know, it wasn't that to go on to the next thing. But this thing is over-engineered like crazy. This little hatch here will let you adjust every single possible thing you can think of. And then, of course, it's a vacuum tube tester, so what do you have in the 50s? Well, if you take this little thing off right here, yeah, there's more vacuum tubes, of course. So, something has to have a power supply in here. And so there's all the regulators and other tubes that make the vacuum tube tester run to test the tubes. But if you look into the specs of this thing, you can program this for plate voltages at 1/10 of a volt increments, all the way up to 400 volts. You can program the grid. You can program the grid voltage. You can program current. You can write a little program to decode this if you want to understand what this is actually doing. And just imagine the amount of effort required to do all of this. So for those of you who like engineering, if I had some time, more time, I could lift this. There's this enormous transformer in here with probably about 100 taps on it to get you all the different voltages that you could then combine. And Mike might know this. There's a light bulb in here. There's a 100-watt light bulb in here. Why? Well, let's suppose you short the output. Anybody use a dim bulb tester? There's one buried in the middle here. So if you've got a shorted tube, there's this funny glow that happens because the 100-watt light bulb will come on and say, oh, well, I'm not going to let the transformer burn out. They built that in here. It's just totally nuts. So I just appreciate over-engineering like this, and they included all kinds of different tubes here, including 4-pin tubes. As some people know, you go all the way back to type, 40-something. They included that socket all the way up to the little tiny nuvistors. They actually have a nuvistor socket here. So as tubes went along, they brought this up. So it will rip your arm off if you're trying to drag it along, but it is amazing. Final thing I'll show you about this is that if you want to calibrate this thing, one of the calibration steps was to plug this in. This has a mercury battery. So the mercury battery had a fixed voltage, and so when you plug that in, you put one of the cards in here, you would make sure that the needle went up to a certain point. Well, this was calibrated in 1960. So in 1960, we know what the mercury battery, this is long since gone. So what you end up having to do these days is make your own calibration cell, which I did in this tiny little box here, which is basically just a Zener and a couple of calibrated resistors. And you plug that in right here, and then you can repeat the calibration, but not have to try to go find a mercury battery and disassemble this. So this is what people used to have to do, right?
So where did you get it?
Aha! I don't know if I'm going to tell you that. No, this was literally at an estate sale, and there was a whole bunch. It's up in New Hampshire. The Twin States Club. Is that right? It's a little farther up in New Hampshire, right? There was a ham that had, this was a silent key estate, and this thing was lying in the corner. I'm like, what is all this? And then I opened this box. It turns out, by the way, that a full set of cards like this is reasonably hard to find. And there are even people who are trying to get somebody to scan every single bloody card and replicate them so that they can use a 3D printer and a laser cutter and make their own tube cards, which seems a little extreme to me. But this was made by Hickok. And Hickok was kind of like the ne plus ultra of testers. And so this is the same thing as a Hickok 123. It's a cardmadic, which is this thing here, which is, again, crazy. But it works. We've, believe it or not, most of the caps are okay. And right now, this calibrates to 1%. After sitting there for 50 years, maybe. So, again, if you engineer this right, this stuff, and, you know, this is built like it's going to rattle around in the back of a truck, maybe occasionally fall out of the truck or something, and it just works. But that's another reason why it weighs about 50,000 pounds. And if you look finally on here, you will see that this was owned by, it says toll test set here, which is, of course, what they would be doing. The guy responsible for the long distance toll circuits would have one of these in the back of the truck if they wanted to make sure that the long line between one town and another was not functioning. You had to get that going again. Does anybody here, I mean, I still have a landline in my house. How many people actually have a landline in their house?
A real landline?
Like a real copper landline. All right. I hate to say this, I have a rotary phone from 1956 as well. And it still works. The telephone system still requires that a rotary dial works. It's fun to get people of a certain age and point them at the phone. They don't even know where to put their finger. You know, what right, and then you've got to wait till that. But there's a central office about 2 blocks from my house. If you ever notice the central offices, they're always little 1-story brick buildings, and they have very small, sort of thick windows. And if you look in there, you see now these days a lot of empty space because they were designed for mechanical crossbar switches. They went to electronic crossbar switches, and then they didn't need as much space. And if anybody knows about the deregulation of the Bell system, which happened in '84, I think, there was a lawsuit about monopolies. Some people here may remember that, you know, Sprint and other people started selling long distance service, and the government said, hey, you have to use these lines that were partially, you know, supported by the government. But that didn't mean that they had to give them easy access to the central office. So if you see the central office, you'll see 2 doors. One of them goes into a little cage, and that's the third-party equipment. The other one goes into the room with all the room. So the guys who worked for the former Bell system got to go into the nice door and work in nice comfort while the other people were crammed into this little, door trying to do all their work because they had to have access to some of the lines, didn't have to make it easy. So next time you're in one of those going by, just look in the window. It's kind of, you have to think about that. But the old Bell system, they did everything right.
Very interesting.
I'll change the sign from this to this.
Here you go. Sorry about that.
Oh, you're good. Come on, guys. We're still working. We're not done.
All right.
Be patient.
So I'm Paul, KC1YMR, and
Listen up! Come on, we got a speaker.
all right. So this is probably old news to a lot of people in this room who probably grew up with these things, but this is cool to me because I didn't grow up with this, and I think some younger people probably also didn't grow up with this. But this is a Tektronix 475M oscilloscope. It has 2 channels. It goes to 200 megahertz, which is the fastest scope that I currently own. So even the digital stuff can't keep up with this. It is not tube, but it is 100% analog. There's no like microcontrollers or anything in here. It's all analog. I don't even know if there's any integrated. There might be a few integrated circuits in it. I used to have a schematic. I lost it. But it is all analog. It's all knobs and dials. It's got this CRT that, it takes like a good 10 seconds before it actually starts doing something useful. And like a lot of people might be familiar with modern oscilloscopes, you have the single shot function where you can take a shot of like one like pass or sweep. This will do that too. However, it's got an output on the back here to connect to a thing that you would buy that was called a scope camera. And so it would be like a Polaroid type deal, and it would fire that and it would take a picture of what happened because the tube obviously has no storage. And it's also got this multimeter on top that does work. It's not very useful in a modern context, but it is pretty cool. So that's this thing. That's, like I said, a lot of you people probably think that this is normal and boring. I think this is very cool because I I learned how to use digital scopes, and then I got this thing, and I like it.
Where did you get it?
A family friend of my parents was cleaning out his basement, and he thought that I might like this thing, and he was right. Yeah. So this, right? He was right. He was right. I definitely enjoyed this thing very much. This is the other thing. This is way more interesting. So this is a QRP-Labs QMX Plus transceiver that is a little bit damaged because it took a fall in the parking lot out there before, and so now it's a little bit bent. So I'm going to have to fix that later. But this is a kit that I built. You order it online. This does 6 meters through 160, digital CW and single sideband. 5 watts output, roughly. Some bands a little bit more, some of them are a little bit less. It is a SDR based thing. So it's got a ST Microelectronics DSP processor, and it's got an RTC, it'll do whisper, it's got a GPS. I guess what other things are interesting about this? It has a built-in, it does cat control, it has a built-in USB sound card, so it's supposedly really good if you do FT8. I've not done that with it yet. And I built this from scratch, wound all these coils. It doesn't really talk about this in the manual, but you can tune it and get more power output. So like, for example, the 10 meter band, I was only getting about 3.5 watts when I first built it. And so I tweaked some of the low pass filters and I got it up to about 4.5 watts of output. It has a built-in SWR bridge and RF power meter, so you can tune that. And it has a crazy amount of tests that this thing can run. It can sweep all the low pass filters. It can like draw you a little graph over a serial terminal of what the different filters look like, so you can tune them. The band pass filters for the receiver and the low pass filters for the output. And yeah, I've gotten, with just this and a 10 meter dipole, I've gotten pretty good DX to Europe with it. And it's, I didn't have enough time last weekend, but I did get a bunch of stations in France and Belgium with on the ARL 10 meter contest last weekend. So, and then for a microphone, it doesn't come with one, but this is a 3D print that I have access to, a 3D printer at work. So this is for you with the 3D printing. Oh no, it escaped. But there's a little microphone element. Now we got the cascade of things dropping. A microphone element, a PTT switch, and a little 3.5 millimeter jack in here. And there's also a calibration process for this that this thing will run to tune the microphone for, I don't understand this part, but it's basically like tuning like harmonics of the microphone or something. It's really cool. The software in this and what it can do is crazy. And then do I got anything else in here? This is a 20 meter dipole that I built with Les at Bruce's technician class. And this is a dummy load because I didn't want to buy one because I didn't have the money. And so I got from work a couple 100 ohm resistors, this BNC cable or connector, and these are non-inductive resistors. And a friend of mine who has a VNA tested this, and it's not a perfect dummy load, but up to about 100 megahertz, it is under 1.1 SWR.
So fine for the
Fine for this, yeah, because this only goes up to 6 meters, so this is totally fine for that. So yeah.
Question: Did the kit work when you first turned it on after building it?
Yes, it did. It worked when I first turned it on after building it, and then I had to spend a bunch of time messing with the different filters at the higher power level.